Hey there, today we're going to be talking about inclines. It's not every day that I see an incline, especially that I'm doing this video in the middle of the the coronavirus. So, inclines are very wonderful sights, and sometimes I'm walking up the hill, and I really feel that it's harder for me to move. Now, hopefully by the end of the lesson, you're going to understand the forces that act on you when you're on an incline. And most importantly, you're going to be able to bring a good score on the SAT physics exam or whatever exam it is that you're setting for. So we have a box, and this box is an incline that is of 30 degrees. So we have 30 degrees right over here. Now the box is 5 kilograms heavy, so the mass is 5 kilograms, and its weight is 50 newtons. So let's just do a diagram for this box, all right? So what are the forces acting on this object? Well, we have a force acting fully downwards, and of course an opposite. We have a force acting in this direction, and normal force. And of course the object is stationary, so there is a force in this direction, and equal and opposite, it's in this direction as well. I'm sorry, I wasn't that good of a drawer. That's why I'm doing physics, by the way. But you get the point. So since the object is 50 newtons, okay, 50 newtons is in this direction right over here. Now, I want to do something here that isn't like very conventional. Now, do you see this downward area right over here? I'm going to complete the triangle in this fashion and in this way. And I'm going to transfer the 30 over here. It's the same angle. So we will have this is equal to, this is a perpendicular triangle. So this is 50 Newton. And since we are trying to bring the x component here, the y component there, this will equal 50 of cosine 30. Times cosine 30. And this component right over here will equal 50 times sine 30. And this component is barely this, it is the same as this component right over here. So you'll get 50 times sine of 30. And this is 50 times cosine of 30. So 50 sine 30 is half. So we know that for sure is 25 newtons. So 25 newtons is pulling down on the object to slide. So we also know that since this is acting, we have a normal force. And so we know the normal force is equal to 50 cosine 30. Since this is equal to 50 cosine 30, the opposite and equal force, the normal force, to this plane is equal to 50 multiplied by cosine 30. So the normal force is known, and the force that is parallel to the incline is equal to 50 multiplied by sine 30. And just to go a final step further, to understand the coefficient of friction, well, we know that the friction force, to determine the frictional force of a static object, we bring the normal force and multiply it by the coefficient of friction. So we know that we know the friction force. We know the normal force, excuse me. So the normal force has been determined. So if we multiply that by the coefficient force, we will be able to bring out the friction of the object. Right? Well, I hate to say it, that is not the right way. Now, you see, this is a trick that some people don't understand. Now, since there is an object actually, and it's not moving, we have the frictional force is equal to F of forward. The frictional force acting on this object is equal to 50 sine 30. It has nothing to do with the coefficient. We only use coefficient times normal force when the object is moving. So 50 multiplied by sine 30 is equal to the frictional force. And of course, it's pointing out in the other direction. This is the frictional force. This is the force that's trying to move it. And I really hope you have a great time. Stay home and stay safe during the coronavirus epidemic. That was an incline problem, and hopefully you get an intuition of how this works. Thank you very much. Oh, it didn't stop.